In example 5, we need to prove that these two triangles here are congruent, ABC and EDC. At first glance, it doesn't kind of look like that. It looks like they're off just a little bit, but looks can be deceiving. This diagram may not be drawn to scale. What we want to do is use our given information to see if we are allowed to prove that that's the case. So that's where we'll start here. We'll start with our given information that AB is parallel to ED. So let's use our parallel marks. There's a parallel mark and DE. And once again, or ED, once again, it doesn't really actually look like these are parallel. The figure is not drawn very well, but if we're given that information, we are allowed to make that conclusion. Number 2 here, AC is congruent to EC. So let's make that mark, or the tick marks here on the diagram. AC is this one, congruent to EC. There we are. Alright, and that was given. We cannot prove that these two triangles are congruent. We only know they share a side that is congruent. We need at least 2 more pieces of information in a specific order to be able to do that. So one thing I'm noticing right away, and the rest of these can be almost in any order, but one thing I am noticing is that I have a pair of vertical angles right here. So we could say that angle ACB is congruent, so ACB is this one, to DCE. And the reason is not that it's given. The reason is that vertical angles are congruent. Absolutely they are. And there they are, there's vertical angles, they're congruent. So this reason allows me to make this statement, and that's right here in the diagram. Number 4, well, this one's a little tougher, but I'm going to imagine here that this kind of keeps going, and imagine that this one keeps going, and they're supposed to be parallel. That would make this line right here a transversal. And if we look at this angle here and this angle here, those two angles are on alternate sides of the transversal, but they're on the interior of the parallel lines. So we call these angles alternate interior angles. We know that alternate interior angles are congruent, so we can state here that alternate interior angles are congruent. And we need to actually state here the angles on the left. So BAC will be the first one. A couple different ways to label that. You could just label it A if you wanted to. That'd be fine. Probably a little bit easier that way. But we'll go with this, the 3-letter naming convention here. So then we've got DEC also. That's the other angle right there. Now, if we look, we have 3 pieces of information between the two triangles that are congruent. And so, in this case, we are allowed to make the conclusion that ABC is congruent to triangle EDC. And we'll write that down. There's a postulate here that we need to use, and we'll just look at the order of the pieces of information that we have. So we have angle, side, angle, and angle, side, angle. Of course, it needs to be the same, and we'll write down then angle, side, angle, or ASA. In between the two angles is where the side is, so that's why the S appears right in the middle.